Okay, so these notes are over solving systems using elimination. So just a different method of solving systems. So for elimination, which it's already worked out, but this is our original system right here. For elimination, you're wanting to take one of your variables. It doesn't matter whether it's x or y, but you're wanting to take one of your variables in each equation and have them be what I call opposites, which I know isn't the technical term, but you want them to be opposites of each other. So if one of your equations has a positive 9x, then you want your other equation to have a negative 9x. If one of your equations has a positive 3y, then you want the other equation to have a negative 3y. And I know that's not the technical term for it, but that's how I talk about it because my kids remember it better. So in my equations, I've got negative 2x plus 7y equals 10, and x minus 3y equals negative 3. So what I can do to have our equations have opposites is the top equation has negative 2x. So I can take my entire second equation and multiply by a positive 2, and that'll make my bottom equation have a positive 2x. So now I have 2x plus 7y equals 10, and positive 2x minus 6y equals negative 6. So that 2 gets distributed to all three of those. Once you've done that, you make it a big addition problem, and you add going down. So negative 2x plus positive 2x, that's 0, that's gone. 7y plus negative 6y is 1y, and that equals 10 plus negative 6, which is 4. So right off the bat, you found that y equals 4. Now you can take what y equals and plug it into one of your equations for y, which I just did the first one. So I have negative 2x plus 7 times 4 equals 10. So now I have negative 2x plus 28 equals 10. Subtract 28. So, ooh, that was really ugly. So I get negative 2x equals negative 18. Divide both sides by negative 2. So we get that x equals 9. So our solution is 9, 4. So you take one of your variables in one of your equations and you try to have one be a positive and one be negative of the same number so that you can eliminate that variable. So here I have 5x plus 4y equals 6 and negative 2x minus 3y equals negative 10. So I've got a coefficient of 5 and a coefficient of negative 2 for x. I've got a coefficient of 4 for y and a coefficient of negative 3 for y. So I can approach this several different ways. Let's just say I want to eliminate x. So if I want to eliminate x, there's nothing I can do to one of these equations to make one be 5 or to make the other be negative 2. So I'm going to take my entire first equation and multiply it by a negative 2. And I'll take my entire second equation and multiply it by a positive 5. I'm sorry, no, the first equation I'm going to multiply by a positive 2. I'm sorry. And the reason why is because that'll make my top equation have 10x and my bottom equation will be negative 10x. So my new equations are 10x plus 8y equals 12. And negative 10x minus 15y equals negative 5. And now we make it a big addition problem. So 10x plus negative 10x means the x's are gone. 8y plus negative 15y is negative 7y, and that equals 12 plus negative 5, which is 7. So negative 7y equals 7, so now I can divide both sides by negative 7, and I get that y equals negative 1. So now that I've solved for y, I can take what y equals, and I can plug it into one of my equations. It does not matter which one. So I'm just going to do the top equation and plug it in for y. So I have 5x plus 4 times negative 1 equals 6. So 5x, minus 4 equals 6. I'm going to add 4 to each side. So I get that 5x equals 10 and divide by divide by 5. So I get that x equals 2. So my solution is 2, -1. I could have approached this exact equation totally different. So this exact system I could have approached totally different. I could have eliminated y from the very beginning. So here on the right I have the exact same system. But if I wanted to eliminate y, what I could do is I could have multiplied my top equation by a +3 and my bottom equation by a +4. And by doing that, I would get 12y in my top and -12y in the bottom, and those would eliminate. So that would be 15x plus 12y equals 18, and -8x minus 12y equals -4. Okay, make it a big addition problem. So 15x plus -8x is 7x. 12y plus -12y is gone, and that equals 18 plus -4, which would be 14. Divide by 7, so I get that x equals 2, which we said we would get to in the other way that we solved it as well. And now I'm just going to take 2 and I'm going to plug it into one of my equations. I'm just going to do the top equation. So 5 times 2 plus 4y equals 6. So 10 plus 4y equals 6. Now I can subtract 10. So 4y equals -4. Divide by 4, so I get that y equals -1. So my solution is 2, -1. I get the exact same answer, but I approached it 2 totally different ways. So there is not just one right answer one right way to solve this whenever you're working these out. You just need to pick a variable and eliminate it from the beginning. All right, I have 12x plus 8y equals -8, and 3x plus 4y equals 2. So I need to eliminate one of my variables. It doesn't matter which one. So I've got 12x and 3x, 8y and 4y, so it doesn't matter. I'm just going to go ahead and eliminate x. And the way that I could eliminate x is if I multiply my bottom equation by -4, the top equation will have 12x, and the bottom equation will be -12x. And that will help us eliminate it. So I'll have 12x plus 8y equals -8. And then -12 at, that's not a 12. -12x minus 16y equals -8. Now I can make it a big addition problem. So 12x plus -12x, the x's are gone. 8y plus -16y is -8y equals -8 plus -8 is -16. Divide both sides by -8, so I get that y equals +2. Now I can take +2 and plug it into one of my equations. It doesn't matter which one. I'm just going to do the top one. So 12x plus 8 times 2 equals -8. So 12x plus 16 equals -8. Now I'm going to subtract 16. Ooh, that's subtraction. So 12x equals -24. Divide by 12, so I get that x equals -2. So my solution is -2, 2. And that is it for solving systems using elimination.